So what we're going to do is, the first thing, we're going to work on R1, because it's the first one we get to, and it's the easiest because it's on its own. So on R1, we can say, because it's a parallel circuit, we know the voltage on R1 is going to be 6 volts. So that's going to be the voltage on this resistor, and 6 volts is going to be acting on both of these. So this voltage plus that voltage is going to give us 6. So we know at the moment R1 the voltage is 6 volts. We know the resistance is 4 ohms, and we can work out the current quite easily because it's going to be V divided by R. So in our case it's 6 divided by 4. So we get 1.5 amps. So we know 1.5 amps of current is headed towards this resistor over here. So 1.5 amps is going that direction. The rest of it is going to go over here. So whatever's left over, so 1.96 minus 1.5 is going to be headed in this downward direction. So 0.46 amps is going downwards. So what we can do to start doing now is we can start working on R2 and R3 as well. So they're both going to be different. The one thing I know is going to be the same for them is going to be the current. That's because current in a series circuit doesn't split. It would go through here, it would also go through over there. So I on this is 0.46 amps, and the I on this is 0.46 amps as well. We know the resistance on this is 3 ohms, and the resistance on this one is 10 ohms. So we can work out now the total voltage on this one, and we can work out the total voltage on this one, because V is equal to IR. So 0.46 times by 3 is going to give us 1.38 volts on this one, and on this one it's going to be 0.46 times by 10, which is 4.6 volts. Sorry. So 4.6 plus 1.38 should give us a total value of 6 volts, and at the moment it's giving us a value plus 4.6 of 5.98 volts, and that's because of rounding errors. So we can say it is 6 volts, so it's okay. So that's a good check to do on this. So what we've done there is we've worked out the IRV on R2, the IRV on R3, and also the IR and V on R1. So that's how you solve that circuit.